Alright, so let's move on to the next topic. It's security enhanced Linux. So far, with respect to security, we have seen regarding there is a term called DAC, discretionary access controls. That means our read, write, execute. Okay, and we have what do you say, SUID, setting up the bits SUID, SGID, and sticky bit, all those things. So one thing, if you have observed here in all these permissions we have seen so far, is that the owner will be able to perform any kind of operation on the files, right? So not only that, but any user can gain the root access over the set of processes or the files. So that is something which is there with respect to all these kinds of permissions that we have seen so far. But above all these levels, if you want to have somewhat more advanced security, such that even users who have root access should not misutilize it. Okay, so that is the level of security that if you are expecting. So that is something which is possible in SELinux, that is Security Advanced Linux. So here what happens is SELinux is basically, it is part of your kernel's feature. It has a few modules. The kernel has a few modules with respect to SELinux. So the completely the kind of restrictions that are imposed are at a system level. Okay, and it does not check for if I mean, in order to implement something, it will not check for the owner of the file or the process. Okay, so the kernel maintains a set of rules, or we can also call it as a set of policies. Okay, it's like the kernel maintains these policies, and by default it always denies with respect to any kind of request that comes regarding any kind of operation. The default rule is no, do not execute it. All right, so what happens is we need to have these policies. So for any particular service or any kind of operation you wanted to perform, so if you send out a request to the kernel, there must be an explicit rule defined that says that okay, so this can be allowed. So by default it's like blocking everything, okay, in your system, and then if you explicitly want something to happen, so you need to define that as a part of that policy, and only that particular process will work, or that would get executed, or the access is permitted or granted. All right, so you can see this, or I can give you another better example here. Take all the set of files, all right, directories, all these things, different kinds of files, everything. All right, so all these things, they consider it as consider them as one identity, and all the services or the processes that are running in your system, they consider them as another identity. All right, so in order to make these processes, all right, consume any of these files, or the sockets, or the pipe files, or any of these things, in order to have an interaction between these two, so the SE layer comes in between. So there must be policies that define the communication in between these two objects. All right, the source and as well as the file object or the destination object which is there. Okay, so this is the extent to which restrictions will be imposed using SELinux. Okay, so we'll see all what is the how to enable SELinux and what are the other features of SELinux are. So I mean, by default at the time of installation itself, you will be asked whether you want to enable SELinux or not. So ideally there are three modes of SELinux. and we should always, it is very mandatory. In fact, it is mandatory, it is very important that SELinux is always in a enabled, it is always in an enabled state. And you can see that information in etc sysconfig SELinux. Okay, so this is the configuration file. So if you see here, these are the three states: enforcing, permissive, and the other one is disabled. All right, so so the SELinux must be always set to the enforcing mode. Okay, so then it will implement all the security policies which are present as a part of the SELinux modules. Okay, and then we have the next one called as the permissive mode. This is the mode in which what happens is SELinux will try to warn the users whenever you request something. It will warn you that, okay, so this is so this kind of situation might arise. Like that, it will try to print the warnings, all right, in a permissive mode, but it will not stop the user from performing the operation. So you can make use of this mode usually in your test environment or a dev environment when you are testing some applications or something. So it will be useful over there, but always in a production, it is always recommended to make it enforcing. And disabled, though it is available, so it is not at all recommended to have this particular state. Okay, and then we have something called SELinux type. Okay, so there are three different types. One is targeted. This is where it tries to implement all the features that SELinux has on all the types of processes, and this is in fact the default type that must be set. And another one, there is another type that is missing here, that is minimum type, wherein only a limited set of services will have the SELinux enabled for them. Okay, a limited set of services. So and just like the status or the state of SELinux, you can also set it to minimum when you are in a testing phase. And the third one is MLS. It's a multi-level security protection. As of now, we don't need this. It's much more advanced than SELinux itself, so we'll not be covering this here. So this is the file that takes care of it. So if you want to check the status, there are get enforce is the command, and that will tell you about the current status of SELinux in your system. And if you want to manually change the current status, say set enforce. All right, so you need to provide arguments. Set enforce space. If you give one, automatically, so these are the corresponding parameters. Okay, set enforce space. I can either give it as permissive, or I can also pass the corresponding value. Okay, so here, sorry, it must be 0. So temporarily it has been changed to permissive mode. Similarly, again, I'll just revert it back. So this is a temporary change. So if you want to make it a permanent change, you need to update that inside the file, or I think from the command line, you can also do that by giving a -p argument. Set I'm just quickly checking that in one page. -p, it's not there. All right. So let's see what is there in the presentation, and I'll give you some more examples. All right, if you want to check the current status, SE state, let me see. Okay, so in my system, this is the current status. It has been properly enabled. Okay, this is the mount point. This is the current mode. Okay, SELinux type, SELinux is enabled. As a part of the SELinux, as I've mentioned, there are policies involved, and along with the policies, we also have a set of Booleans present. All right. So when I say Booleans, they're just like on-off switches. Okay. So I'll show you for every service or in every application there will be a set of Booleans present in the system. Okay. So we can either enable them or we can disable those Booleans. It's like for a particular application. Imagine for a particular application there are a set of SELinux features. Okay, so when I say set of features, for every feature say there is a Boolean which is a switch. Okay, so this feature you can either enable it or disable it like that. So there are multiple SELinux features for a particular service. So I think one second. All right, so these are the default services for which SELinux is currently enabled. So we have the configuration file under etc sestatus.conf. Here you can see. So these are the file contents. All right. So I forgot to show you one more thing. So if you want to, how do you check whether SELinux is there? How do you identify the kind of restrictions or what kind of parameters are involved? All right. So for ls, along with ls, if you give -Z. Okay. So I'll show you the difference between the two. So I did an ls-l, okay, which is the normal way, and now ls-z with SELinux context. Okay, so here comparing these two, if you observe, so these are the additional attributes that are present that would come up along with SELinux. All right, so going through all this, these are 4 attributes. One is at a user level, and so this is the type of access, and this is something which, let me check that I missed this. All right, so among all these 3, all right, so we would be mostly modifying the type which is present, that is the 3rd parameter. All right, so for any kind of service, it is the type that matters. We need to enable the corresponding type which is present. Okay, so SE module -L, you can get to see the total list of modules which are present inside your kernel, SELinux related modules, and okay, so this is a quick example. So before, let me show the same on my system. Okay, let's take this typical example of applying SELinux on an Apache server. Okay, so we have seen Apache server configuration before. So we install etc httpd packages. Once we have installed, we open the http configuration file, and inside the configuration file there are a few parameters that we have to change. The first one is the document root. If you remember, /var www HTML is the default document root that your configuration file will be pointing to, right? So inside the document root there is something called index.html. So by default, once you install your Apache service and you start your Apache service, so it will show you the index.html page, right? So now say let's check this ls-z where www HTML. See here, if you see, there are some HTTP specific types which are present here. All right. So by default, along with the HTTP service, these types are enabled for these files and folders which are present under var www html. So whatever content that you place here, see this. So this would be more interesting here if you observe, right? So the user and the first two parameters are the same. Observe the third parameter. So this is what HTTP says script execution. That means the SELinux has been enabled and it allows the users to execute scripts from this folder. Alright, and similarly, if you are setting up some HTML pages, so this is the corresponding SELinux field that must be enabled. The reason why I'm showing these fields is, say you want to change your document root, rather than keeping under var www, you want to keep it somewhere, say under the slash. Alright, then what you have to do is, so ideally the first important thing, so you have created a folder under slash, okay, you named it something and you want to keep all your HTML or CGI bin files under that folder, okay. So if SELinux is enabled, it will not allow you, okay, to make use of that folder unless you explicitly set up this type to the file and the folders which you have newly created. So that is what is SELinux. That is how SELinux restricts. So by default, when you install the service, there are some default files and folders you have created, and there is an SELinux set on them. So all the SELinux policies are set. But if you want to change the default ones, alright, so the SELinux will block you. So if you create a new folder and if you want to use that folder as a document root, so the first thing usually what you do is, inside our etc httpd configuration file, so what we do is we change the document root to some other folder. Alright, so ideally if SELinux is disabled, alright, automatically what happens is we will be able to make use of that document root if SELinux is disabled. But if SELinux is enabled, simply changing the document root is not sufficient, okay. Again, what we have to do is we need to give the appropriate context or the appropriate type to the files and folders that we have newly created as the document root, okay. So and the command, if you can see here, chcon, just like we use chmod command to change the permissions, to change the group and owner of the files and folders, similarly we use chcon command to change the context of the file and folder. Here if you see -t is the type, that is the third field. If you want to change the third field, chcon -t type sample file, okay. And similarly, say you want to change the first field, then you have to mention -u, chcon -u, and alright, so yes, the middle one is the role, so user, role and the type. So among this, so this is the role, okay, object role, and this is the system user, okay, and then the third one is the type. So you do not have to worry about the first two parameters. You just have to ensure that if you change your document root, whatever existing permissions are there, you can set similar permissions. Then only, so you have, if you want to run CGI scripts from the new location, you need to set httpd script exec on the new file and folder, okay. So let's try that. I'll create something, mkdir, and say cgi-bin. So if you observe here, so actually I have created a folder with httpd sys content. So whatever existing context is there, automatically it would get applicable for all the new files and folders. Now I want to change this context. So chcon, alright, -t, and I'll say httpd sys scripts _ t cgi bin. Okay, now this is not there. Okay, httpd sys script. Okay, now see this. Now I have created this. So this is how it will allow me to execute CJ scripts from this folder. Similarly, if I want to change the user, alright, here there is something called unconfined underscore u. I want to ensure that the same user is present. Okay, so this is how we make the changes, and we ensure that the same set of properties have been set to the newly created files and folders. So automatically the HTTP service will be able to pick these things once these are set, even if SELinux is enabled. So this is how for any of the new applications. So if you have observed here, by default everything is blocked. By default things are not allowed to get executed. Even if you have root privileges, you'll not be able to run your services as per your wish on newly created folders or files. Okay, so we need to explicitly define the rules, define the booleans. Okay, then only the service will be allowed through the SELinux policy. Okay, so and one final command here is the restore con command. Say you have applied some policies newly on a set of files and folders, but you wanted to revert those changes whatever you have newly set. Restore con command will help you to restore all the attributes that you have set to the default state. That means the time you have created a file or a folder, whatever context was there, it will help you to restore the context to the original values. Okay, so here are some of the commands for your reference. You can simply go through and try these commands. So as I've said regarding the booleans, they are like on-off switches. So get sebool is the command. You can see the list of all the booleans that are present in your system. So if you observe this, all right, so with respect to FTP service, you can see there are a couple of booleans that are present. So if you flip or enable the corresponding boolean, then that automatically then that feature will be allowed to pass through the SELinux policies. Like that we can have multiple different policies set, or the booleans set in the system for every service. Okay, so that's pretty much about the SELinux part. Then we will move on to there are just a few more topics left. It's almost like we are done with most of the, we are done with the syllabus. So a few small topics that are left. We have seen how to log in into single user mode, right? So there is a need to restrict the users. If there is a need to restrict the users, it is always mandatory to set up a password so that the users will not be able to log in into the single user mode. Just like we have a BIOS password set, similarly we can also set up a password so that the users will not be able to open the moment they try to access the grub console, we will be asking to provide the password. Alright, so this process excuse me, so this process it's very simple. So there is a command called grub md5 crypt. Okay, so simply running this command, what happens is it will generate an encrypted password, just like the one we have created an encrypted password with SSH, right? We have copied that password to the source and destination. Like that, there will be a password that this command would generate. We simply have to add this password So this is an encrypted password, so it will prompt you to give the password twice. Once you give it, it will generate an encrypted password. So as an administrator, you can keep this encrypted password inside your grub.conf configuration file. Okay, so once you keep it inside, whenever we try to open the grub menu, so the grub menu is nothing but your grub.configuration file, right? So what it does is it will start reading the grub.conf, and inside grub.conf there will be a first argument requesting the user to provide the password for the grub. So once you give the password, then only the user will be allowed to proceed with the menu. If you can see here, password space, this is MD5 algorithm that has been used, encryption algorithm. So using that, so this is the password. Alright, so as soon as you enter the grub, the first step, that is your password. You give the password, and then you will get to see the hidden menu which is there. So we are blocking the user before entering the hidden menu itself. Okay, so this is an important thing. So it's always recommended to set up password for the grub so that your system will be safe. Okay, so here itself, the moment you enter the grub, it will ask you for a password. You give the password, and then you open the grub menu. Okay, and another topic that we have left, it's a simple one, that is TCP wrappers. Alright, so I will make this very simple before rather than explaining about TCP wrappers first. Let me tell you about two files in the system that will be easy for you to understand. Okay, so there are two files. One is etc hosts.allow. Okay, so etc hosts.allow, etc hosts.deny. These are two important configuration files. So what basically happens is, I mean, the importance of these two files is you can define the services and the users who have access to those services. Similarly, you can define the services and the users who are not allowed to use these services in a network. Alright, let me repeat. So these two files are helpful to define the set of services or a service and the users who are allowed to use the services. Similarly, we can block the users from accessing these services. We can do that at a user level, or we can block across. I mean, we can block a subnet, we can block a network of users. That means at a host level as well as at a subnet level, we can block the users. Now, what are these services? All right, so these are some of the sample services are your your telnet, your SSH, your FTP. All right, so if inside etc hosts.allow, or take this hosts.deny. Okay, if I say that, if I mention that take etc hosts.deny. Okay, so here what I would say, I would mention SSHD. Okay, and this service must be denied for everyone who are present in the network. All right, then automatically what happens is, the very next moment this particular rule will be enabled and no one will be able to SSH into my machine. You getting it right? So like that, there are a set of services. So TCP wrapper is basically the underlying daemon that helps to have a mechanism, using which these features can be enabled and disabled. So that is what is a TCP wrapper. All right. So it provides a layer on top of these existing services, and that is how it tries to allows or blocks the users from making use of the services. So here there are three stages, whether access is explicitly permitted. So by default, if you have seen here, right, there is nothing inside these two files. Hosts.star, right? These are empty files. So explicitly everything has been permitted from everywhere. So this is another way of implementing security on the services in the system, right? Now, so this is the default one, then explicitly denied, explicitly permitted to access the services, right? So three different modes that are available. And so so this is the format. You need to mention the daemon list SSHD the way I have mentioned now, followed by colon space client list. Okay, so let me try this in my network. What I'll do is I'll try to SSH from, this is my Ubuntu machine. From Ubuntu I'll do SSH root at dot. Let me try pinging that first. Perfect. Now SSH root at yes. Second. Okay. Current and C root. There is some issue. Okay. All right. Let me show that here itself. SSH surrend at okay, perfect. I am able to make use of SSH service. Okay, I'll just exit. Then what I'll do is I'll take etc host.deny, and inside that I would say SSHD. I want to block everyone. Okay. Now service xn etd restart. So This is a dependent service. Okay. Okay. So you can see there is an error here. The connection closed by remote host. So it's like I've taken the same machine as a server and a client, and because it has been denied, the SSH has been denied, the users will not be able to log in. Okay, let's quickly cross check by hosts.deny. So this is how the wrapper services work. Okay. There you go. So this is a if you want, you can block users from SSHing. You can block complete users from the network from logging into your system as well. Okay. So this is how the wrapper services work. All right. I guess with this we are done with the topics.